Howdy folks. What I'm going to try to show you today is how we use the emission hood to tune a T-LUD. And so just generally a T-LUD, you use pellets or some small material which you put into a combustion chamber. And it's a batch load of material, and there is bottom air or primary air, and then there's secondary air. And so the batch load of fuel, you light it on top, and then the air which supports the combustion is flowing in through these holes, and it makes a beautiful column of flame where all of the gases and the smoke that are made below by the hot material combine together into a beautiful column of flame. And because all of the gases and smoke go into that column of flame, we get very good combustion. Now, I want to show you what happens when you have a good T-LUD. So here we are, and you see the lines on the screen. This line is the water getting hot. So it's going from ambient temperature all the way up to boil. And in this case, the T-LUD took more than 40 minutes to boil the 5 liters of water, even though we had a 6 mm gap on the skirt. Now, this green line is the flow of the air through the system, so that should remain unchanged. But the blue line is the CO2. And so the CO2 is a good proxy for the power of the stove, and you can see that the power was not very high. The power was only about 2 kilowatts during the whole test. But at 2 kilowatts, although it took more than 40 minutes to boil the water, look at the PM line. There was a small little bit of smoke in the beginning, but then we achieved a flat line condition, which is what we're looking for in a clean T-LUD. And the red line is the CO, so we had very low CO during the entire cooking event. So here we go. We lit the stove. The CO is going up. The temperature is going, the CO2 I mean is going up, so we knew it lit, and the temperature of the water is going up. And here's the red line for the CO. So far the PM has stayed pretty stable. And so the first thing that I'm looking for is, basically all we can do with this T-LUD is adjust the primary and secondary air. All right, so the CO2 is starting to climb, and like I said, that's the proxy for firepower. That's a pretty good indication of firepower. But we're starting to see some bad things. So this is the CO2. This is the water temperature going up. That's good. But look, the smoke, the PM line is really starting to get disturbed and is rising, which is exactly what we don't want to see. And we really don't want to see that CO going up. When we lit the stove, everything was fine. And so this is the PM line. Here's the lighting of the stove, and you can see the CO2 is starting to go up, and that's our good proxy line for firepower. The water started to go up pretty rapidly in the temperature, and then we started to see problems. So the CO was going up really rapidly, and we got this big bump in PM. So what we did was I adjusted the secondary air. So I gave it a lot more secondary air, and that worked. That brought the level of PM down, and it brought the level of CO down. But what happens is that at the same time, I adjusted the primary air, which made the firepower go down. And so it is very low firepower now. So what I'm going to do now is I'm going to try to raise the firepower up to about 2,000 or 3,000 and see how high can I raise the firepower while keeping the PM and the CO flat. So what has happened is we're now at about 60 degrees with the water temperature. We have gone 18 minutes, and the firepower rose back up to around 2 kilowatts. But look what happened. As soon as we went over about 1,400 watts, we started to make a little bit of smoke and make a little bit of CO. So what we can say is that for this TLUD, with this configuration of primary and secondary air, and also with the way that the flame is flowing and all kinds of other sort of architectural issues, that we have to go back down to this lower firepower to achieve the super clean condition. So I'm going to shut down the primary air, and then we'll get back down to as high as CO2 as we can get while trying to get the super clean, no PM and no CO. Well, so I closed off the primary air, and what that is doing is that's lowering the rate of burn, and so you have less fuel created, and the stove can then deal with it. So at about, pretty low, it's maybe, we're getting down really low, like 1,200 watts, we're now seeing what we want. We're seeing flat line for PM, and we're seeing the CO going down towards flat line. And so what we know now very quickly in 20 minutes is, all right, the TLUD in this condition can deal with a little bit over 1,000 watts and be super clean. We need more firepower than that to boil 5 liters in 30 minutes. And so what you see now is a real-time experiment. And what we'll do now is we'll go back, we'll change something in the stove, and then we'll look in real time again at the performance, trying to get that CO2, the firepower, up. And once we get the firepower up to, I'd like it to be 2,500 watts, then we will then switch to the water boiling test with the gravimetric measurement of PM, and then we will be getting closer to having a really improved stove.